Well, thank you for having me. Like Oliver said, my name is Chris Tankersley. I'm the Senior PHP Developer Advocate at Vonage, who's a competitor to Twilio. So I already told Gary, thank you for allowing me to come and speak at this conference. Um, we have some overlap with Twilio, but we're basically a communications platform. I'm actually not going to be speaking much about that part of us today. I want to talk mostly about kind of async and PHP in general, because different languages do things differently, and PHP is in this kind of unique position where we have a lot of async tools, but not a lot is really understood about what's going on under the hood because of the way the language is designed and actually functions. So kind of as to start it off with, what a lot of people ask, what exactly is async? And because this is a proper computer question, the answer is always, it depends. The reason this depends is because async is kind of a loaded term, and it's a co-opted term that gets used quite a bit. So I'm going to look at it more from like a traditional computer science perspective and explain kind of how all of this fits together when it comes to PHP, because asynchronous PHP, especially in other languages, takes advantage of some very specific things in their language constructs and the way that they do threading and all sorts of stuff, which is different than how we have to handle it because of the way PHP is designed. So if we kind of take a step back and we look at normal PHP programming, we do generally what's called procedural programming. And that basically says, given a list of tasks, do step one, then step two, then step three, then step four. Do them in that order and don't deviate from that list. So if we've got this block of code here, we're going to make a new Twitter client. We're going to pass in a new HTTP client. We're going to get all my tweets. Then we're going to make a template. We're going to render that template. This is really easy to write and really easy to follow because you're doing exactly what it says on the tin in the order that's specified. So given that code, the very first thing we actually do is make an HTTP object. Then we make a Twitter object, and then we go down the line. This is really easy to understand because this is what's considered single threaded. We only ever do one thing at a given time. We don't do anything else. The reason a lot of people don't like this is because it's susceptible to what's called blocking. And that means that any individual step can actually stop the execution of everything else in the system until that step is finished. So in the case of this set of code here, when we do the get tweets, we may sit there for a while and wait till we get all of my tweets. Not because our code is slow, but because of things like network traffic, how quickly the Twitter API responds, things like that. Reading the template is also fairly slow in terms of computer time. Actually reading things off of a hard disk can take a really, really long time, especially if you're on a shared system or you're unfortunately on a system that still has magnetic platter disks. The company I worked at before, we could only do one build at a time because a single build would saturate the hard drive. We had to sit there and wait. So if we had multiple builds queued up, we couldn't run them in tandem. Same idea with procedural programming. If it takes a long time to read from the physical hard disk, you're going to sit there and wait until it's all finished. So the best way to think about this is actually to kind of map it out and show what happens, especially when we start to take other things like asynchronous programming into account. So if you're kind of familiar with computer science, there's this idea of a call stack, and this is the list of things that you need to do in your program. So if we take a look at the call stack for a single threaded application, it's going to be just a single call stack that's going to get stuff layered onto it, and it's going to do that work as it comes in. So it's basically a first in, last in, first out kind of stack. So when we start our program, we're going to get this kind of main function call. If you're coming from like C++, things like that, you'll have an actual main function. In PHP, we don't really have that. It's all implicit just from your script. So we have that kind of setup. And then we go do our new HTTP client. That goes on the call stack. Then that might have a require once inside of it, which is going to have some file reads. We do the file read. That pops off. Did my screen share stop? Yes. Am I still going?
I can hear you okay.
Okay. Is it still sharing my screen?
No. I can see
Okay.
you, but I can't see the screen.
Okay, that's weird. Let's go back to there. Hopefully that's back now.
Yeah, that's fine.
Okay. So once we've read the file from disk, then we go back to the step we were doing, which was making it the client. That resolves. Then we start working on the new Twitter client. That's got its own require once. That might have a function inside of it called getM to actually get the Twitter key. So then we do that. That resolves. We finish reading twitter.php. Then that has to get getM for the secret. We go back to reading. That finishes. We go back to the Twitter, the new Twitter invocation. Then we're back to the stop. We go to the new line. And we basically kind of go through this process line by line, doing all the things as we read things into the system. But the way the call stack works is pretty easy. Once you put something on the call stack, we're going to attempt to resolve it as best as possible. Anything that we did before is going to wait until the current operation is done. So you might ask, how does PHP avoid blocking? Because if that's the case, how do we run some of the largest websites in the world? Because Wikipedia doesn't have blocking issues reading. Lots of places run with all of these without any issues whatsoever. Well, kind of in true PHP fashion, we cheat. Web servers like Apache and Nginx are multi-threaded. So whenever we start up a web server, we might start with like 5 instances of Apache, and each of those instances of Apache might have mod PHP running inside there. So we could actually effectively run 5 PHP scripts at once. If we're using something like Nginx, which is using FPM behind it, FPM will actually spin up multiple PHP processes, and then Nginx will talk back to PHP over that FPM linkage and be able to jump between those different threads. So we're still single-threaded, but we kind of cheat either through the web server and let the web server handle all that heavy lifting, or we use that fast CGI process manager that handles all that stuff. The language itself is single-threaded. We don't do anything special when it comes to threads, ignoring the one compiled way you can do PHP, which really doesn't work super great. But this works fairly well because we don't have to worry about it. We let someone else worry about it. This is different than a lot of other languages where they run their own servers. They have to handle all of the threading and all that, the stuff like that. This is also the reason why the development server built into PHP isn't really recommended for production use, because when you start that up, it is a single thread and it will be blocking if you're doing anything. Generally, requests finish very, very quickly. PHP is very efficient nowadays. It is probably one of the fastest web languages out there. We're faster in most processes than Python, much faster than Ruby, because of a lot of the advantages that have come up since PHP 7. So we do our work very quickly and very efficiently, so we can get away with just letting something else thread it. Now, running single-threaded is not the only way to do things. There is also this idea of parallel programming. And the idea behind this is you'll do a series of operations and do them at exactly the same time. So this is basically the complete opposite of what PHP does. PHP, given a list of things to do, does them in order. With parallel computing, you're going to be able to actually execute them at exactly the same time because you're actually going to utilize multiple threads. So in this case, we have some code that's actually going to make some different reports. And if these take a long time to run, we don't want one to block another one. When I worked for a company that did a lot of stuff with Google and like pulling down like Google Analytics and running reports, we had to run them all concurrently, because if we ran them one after the other, it would probably literally take probably close to a week to run everybody's reports if we did them one after the other. So depending on how your language is set up, you can actually go through and split these things out. And let's say we make our object reports, and then we'll actually make 3 different threads. Run a daily balance report, run an end-of-day report, and run a profit loss report. And we'll run those as specific threads all by themselves. Now, some languages will handle all of the scheduling and things like that. Some of the other ones hand them off to the operating system and the CPU. Operating systems are pretty good at this nowadays. If you had to deal with multi-threading, 10, 15 years ago when we were still dealing with like when dual core processors were kind of a new thing. This was kind of a special deal. But nowadays with modern computers, a lot of the stuff is handled by the operating system. You don't really have to think too much about it. You end up just having to think about the actual kind of juggling act that becomes inherent with trying to shuffle data back and forth between these. So this is really where they get really tricky to write. So a lot of people will eschew writing multi-threaded applications for actually like worker queue systems and things like that. But the idea is kind of the same. So if we take a look at it from a call stack perspective, our main application boots up, we get our main function. We're going to run through each of our reports, we're going to generate them. And the difference that we get with this is we're actually going to get multiple call stacks. So we're going to use an extension called PCNTL. And this is an extension that allows you to actually do multi-threading, POSIX multi-threading in PHP. And it will handle creating all the extra threads and doing all that stuff. So we'll actually get a thread for our daily balance. Then that's going to go through and start doing some checking. It checks the PID, the process ID, to figure out whether it's a parent or a child. Because if you're a parent, you can control some things with your children, things like that. So then it's going to kick off the daily balance run. Then we're going to go to the next report. End of day is going to get kicked up. We're going to fork off on that. But we're going to get a second discrete call stack. So now we've actually got 3 call stacks. The main thread, which is handling all of the threads, a daily balance, which is just running that singular report. And then now we're going to have an end of day thread, which is going to handle that report. So we go through the same routine. We're going to fork it, get the call stack. We're going to check to see whether we're a parent or a child, what kind of cleanup work we need to do. Second one's going to start running. So then the fork drops off. Then we start the next report. We fork again. We get our 4th call stack. And this basically happens, and they run all in their own little threads, doing all their own work, not really bothering each other. So no matter how long things take, nothing blocks. So we see here the end of day, that dropped off first. The other 2 continue to run, and they're doing their own thing. And if we just kind of let this run, the main thread will just continue to run in the back end, doing all of its work. It's just going to sit there, wait, and then eventually profit and loss finishes off. Daily balance will sit there and run until it's finished. So the idea with parallel programming, no matter if it's done with threads or workers and queues, is that we will spin up multiple instances of programs and run them at exactly the same time. So now we actually get into async programming, which most of the time when we talk about asynchronous programming, we're talking a little bit about a combination of either both parallel and procedural programming, or kind of cheating. So the general idea behind async programming is given a list of work, try to do as much as simultaneously as possible. So here we've got a little event loop. It's going to do some work. But the idea is we're going to try to do this in the most efficient way as possible, given the workload that we're given. So asynchronous programming is basically still going to be single-threaded. Other languages will cheat a little bit, like JavaScript actually has a couple threads that it can do things. So there's actually the main thread and then an event loop thread. And then sometimes there's an engine thread, either your browser or Node.js. If you're doing this in .NET or Java, it's actually discrete threads. For PHP though, we are stuck with single-threaded applications. So that's the way it works. So we have to cheat and use something that's called an event loop. This is basically going to be a list of work to do. And ideally, those lists of work are very small. And then they can respond back with different bits of data to say either I'm finished with this, go to the next one, or I'm paused with this, feel free to go work on something else for a little bit and deal with that kind of stuff. But ideally, you're going to be doing very quick executions and saving and reducing the number of large blocking operations that you have. So from a call stack perspective, it's basically going to look like a single-threaded application. So here we're going to create an event loop. We're going to go into the main. We're going to create that event loop. It's going to go on the stack. Then we're going to make a new event loop object out of that, probably inside of the factory. Then we're going to make a queue. That's going to drop off. Then we're going to finish up creating our event loop. We're going to throw something in the stack. So then we have this idea of an event queue. So with that queue, we're basically going to keep track of all of the different pieces of work we're going to do. So this first event gets thrown onto the queue, and generally They'll have a callback, you might have a promise, things like that. But we're going to add that event to the queue. So it goes down to the event queue and lives in that SPL queue. That gets dropped off. Then we go add the next event. So that does the same thing, basically. We're going to add that. So now our queue has event 1, event 2. Once the event loop kicks up, it's basically going to block itself until the event queue is basically empty. So once we kick off the run goes on the stack. Then we're going to go through the event queue. So we pop off the first event, which is going to be a little function. It's going to return a random number that returns a 5. We may do something with that 5. In this case, we're probably going to pass it to a callback. So then the callback, so if we get something back, add the callback to the event queue. So now our event queue is event 2, callback 1. Event 1 has finished, it's done, its response gets passed to a callback. So then this kind of drops off a little bit. We call function event 2. That just echoes some things, so it doesn't really need to do anything. So we run it. It just echoes out. We fall back from the echo. And then this kind of process goes through until the event queue itself is resolved. So since we had some sort of event callback for the second event, even though it didn't pass any data to it, we passed in a callback too. So that gets put on the stack. And then this basically continues to happen until the event queue is empty. That is asynchronous programming. Most async programming in PHP technically is just what's called event loop programming. It's a different way to think about how you structure your program as opposed to a true parallel programming where you're actually doing work in discrete units in separate threads. So async is technically just event loop programming. It is not concurrent. So when we put event 1 and event 2 in the event loop, we did event 1, then we did event 2, then we did callback 1, then we did callback 2. At no point did we do those concurrently. We had to wait for one to finish to go on to the next. So technically, it's not non-blocking. So if one of those callbacks or one of those events takes a very long time, it will sit there until that blocking operation has finished. This is where kind of the joke with Node.js comes from. Node.js is not non-blocking. If you throw something in there where it takes forever to read, if it's not written properly, it'll block. I can write some very beautiful blocked Node.js code, just like I can write some very nice ReactPHP code that will instantly block itself. But async doesn't solve the blocking problem. It just helps you with it in a couple different ways. Async is not multi-threaded. At no point during most of the asynchronous ways that PHP works is it multi-threaded. We still are restrained to a single thread that does one unit of work at a single time. And asynchronous is not magic. It is not going to inherently make your application go quicker. When you sit down and you look at things, because it is still single-threaded, you're not going to be able to really reduce the runtime of anything just because operations have a discrete amount of time that they take. Async is not going to just fix all of this. Way back when I was originally writing this talk, I thought one of the cool things I could show off was how fast async actually was compared to just a straight Symfony application running under Apache and that same application running under the dev server. Unbeknownst to me, it turns out running it under the dev server was actually the quickest way to do it, because the things I was doing in the async mode with ReactPHP didn't actually have any impact on whether or not I was blocking. Things executed so quick, it didn't matter. So asynchronous programming generally be used to help better structure your logic. The things that you're doing, you really think about more by what exactly am I doing in this operation? In what order am I doing a lot of this work? Where are kind of my gaps where I am stopping to wait for a lot of things? Asynchronous programming helps you sit down and notice that a lot better. So you think about end results, not necessarily the order of operations. Async is also really great if you don't have to have a specific start and finish other than kick off a bunch of work and then close when we're done. Doing a web server is a really great example of that. You're only going to do work and you're only going to care about work as requests come in. So we can run like a React PHP web server because it will wait for requests to come in, put that on the event loop stack, and then handle them as we get to them. But then we can, very quickly get back around to listening for a new connection. Doing reports is a great way of doing asynchronous programming because you can just kind of let those things flow one to the other. If you're actually putting out a web page, async doesn't really help a whole lot because really you need to figure out what data you need, get that data, throw it in a template and display it kind of in that order. You don't want to accidentally, try to display a page before you have the data come back. So you do need to think about some of those things. Now, that being said, async is a fairly nice way to program, and I'm not trying to talk anybody out of not using asynchronous programming, but there are some things we need to think about in PHP itself. So the bulk of it is the event loop. This is kind of the special sauce that you use to make PHP feel much more async and allow you some of those extra kind of niceties that you get out of asynchronous programming. So if we go back to our little graph here, we have async programming. Basically, we're going to replace that with event loop. Stop thinking about it necessarily as asynchronous programming, but more about event loop programming. So the big thing we focus on is that queue empty? If it's not empty, execute a job. Whether or not it has callbacks are just going to determine whether or not you throw more stuff on the queue. But keep running until your queue's empty, and then your event loop ends. That's the best way to sit down and think about this. Now, there are some things in PHP to make your life easier when it comes to event loop programming and this kind of PHP-ized ideals of async programming. One of the oldest and probably one of the most well-known is ReactPHP. I love ReactPHP. I still use it for many projects. Even though it is a fairly older PHP project, it's still very well maintained. Lots of people still use it for a lot of different things. The way you structure your program, though, gets a little bit different because you're going to have to start breaking it up and thinking about those event loop processes. So here we've got kind of a very simple website. It's just going to return hello world. The thing is, though, we're not really going to execute top to bottom because of the way this works. We're going to structure a lot of stuff when we start the script. It's going to go through, read line 1, then 2, then 3, then 4. But it's not going to execute, from top to bottom specifically. So first off we do is we get an event loop. So we're going to use the React factory, the event loop factory, and create one. Then the next important piece we have is we run that loop. So we actually put some things into the event loop to let it run. First thing we do is we're going to listen on a socket. So we kind of actually jump back up in the processing. Server listen doesn't technically start doing any work until we start the event loop. So we actually kind of jump backwards in this case a little bit. Well, what exactly is a socket? Well, if we go back, a socket is a thing that just listens on a port and an IP address. So here we're just going to listen on every single interface, and that should say 80:80 at the end. But basically listen on an interface, but then we need a loop for that. So which is why we create the loop at the beginning. So we're starting to kind of get these things kind of intersecting and doing things, but not quite in the order we expect. Once we actually get a connection, we need to get a server that actually does the serving. So now we're going to get a basic server object. This is basically a catch-all. So like we're not doing any routing or anything like that. So don't think you're missing anything here. This will literally just take any request and just return hello world. But then we return a response. So a 200 with some headers and some content. But none of this is going to execute until run actually hits. And then inside that run, we're going to be listening for a connection to come in. So there's a whole bunch of other implicit stuff going on with React. But this is a pretty basic React hello world. There's a lot of extra things we need to do in here because we're skewing a web server. This is one of the reasons why PHP is so popular. The web server actually takes care of a lot of work for us, so we don't have to think about. React has a lot of the same setup stuff that web server has. Now, that being said, React is actually really, really efficient in what it does. So once we kind of get this loop running, you're basically going to have a loop that is constant. And that's going to be when you start up, put in a job to listen for a connection. And that job's going to sit there and spin until it gets a connection. Once a connection comes in, it's going to throw another event in the event loop, which is resolve. And then it's going to go through all the resolution and do that. Then at the end of that, it's going to throw another job in the queue that says wait for another connection. And it's going to do this kind of spinning internally, so serving up all of your websites. However, at any one given time, you're only ever dealing with one response. There's nothing special here about being able to serve, 500 people concurrently with this. Technically, you're only ever doing one person at a time, but it's broken up those jobs into some fairly small chunks. Now, if this sounds nice to you and you want to start using this kind of setup for your applications, which is really great for being able to just deploy something to a server without having to have an actual web server, you may want to look at Ratchet PHP. This is built on top of React, and it's a kind of a wrapper for doing kind of HTTP responses as well as WebSocket responses. So this mostly deals with web requests, which really don't need to be asynchronous, but something like a WebSocket request does, because a WebSocket request actually has requests and responses coming back in real time. So with Ratchet PHP, if we take that same kind of general idea, we get a little bit nicer of a wrapper around it. So we're going to basically make a new web server, which encompasses a couple of the same things that React did. So we're going to create a new application. We're going to tell it where to listen. Technically, it's a domain name that it doesn't really use. The port that it's going to listen on, and the interface to listen on. So that took care of a couple of steps we had to do in React. Then we're going to throw in a bunch of routes. So if something comes through, we're going to give it a named route called events. If it hits /events, we're going to pass it off to a controller. Same thing for onAnswer. We're going to pass that to an answers controller. This starts to look like a lot more traditional web application. But in the back end, we're going to start serving this asynchronously. And then there's a special route called a socket. We can actually pass a web socket back and be able to have real-time communication with something. Then when we kick off the run, then it's going to sit there and it's going to wait for something to happen. Now, in the case of the WebSocket, you could do a couple different things, but basically it's going to push down some information, and then you actually have the option to push information back up. But in this case, this is actually taken from a little app I did with our voice API. You can connect to, our voice API will connect to your WebSocket and actually start to push information down on demand as you get a call. So here we have, it's actually the WebSocket we created at the top of here. So we have a socket, new socket, doing some work. And then whenever anything comes in, we push that controller to that WebSocket. So we're going to get the event that comes in, because everything comes in through frames on a WebSocket. And you basically just get a stream of frames, and we have to deal with the frames as they come in. We're going to JSON decode that. If we have an event in there, we'll check it through a switch. We'll check to see if it's a dial tone, like someone actually pushed a button on the phone. And if it is, we're going to go through and do some work for it. So we're going to basically extrapolate that, send back some text that says you pressed whatever number, and then go from there. If it's, so basically the frames are going to come down and keep doing all that. If it's not a JSON, like a text thing, then we'll actually take the contents and put it in a WAV file, and we'll deal with that and actually can record the conversation that way, which is pretty cool. But all of this is coming streamed down from the WebSocket in real time. So basically Ratchet will get a frame, throw it in the event queue, it gets passed on to onMessage, and it handles it almost in complete real time. But because it's PHP, we're actually running an event loop. So as these things come down, they're just being put in the event loop, and we'll kind of get around to them when we get to them. Things happen so quickly though, it looks almost instantaneous. So now most of what we've been dealing with are callbacks, and that's the way a lot of React code works. The callback structure gets really, really ugly really, really quick. If you've done a lot of Node in the past, this is probably one thing that's probably turned you off, just because it's such a bear to maintain. Promises are designed to deal with something called callback hell. So the way generally event loops work is you have some event that kicks something off, and when that event finishes, it's going to call something else. Now, that thing you call may have more work to do, so it may call something else as well. So you end up with these nested lists of callbacks. So if you've ever played around with like array filter is a really good example of do a bit of work and then pass that into something else. What you can do with that, though, is actually filter things down and have that pass into more array filters, and you can end up with something like this. So let's say we want to get back a list of users that are active and they're from Wales. So here we have 3 criteria: that they're active, whatever that means, like they have an active flag on. Let's say they want to have a balance, and that they're from a specific country. So if we use array filter for that, we can get a big list of users, pass that in, and then slowly filter them down. But it's a pain to read this code. So if I break it down, first we're going to call array filter. That's going to take a function, which is array filter. That's going to take a function, which is array filter. And then that's going to take the list of users. That's going to have a callback, or that's going to call into a function that takes a specific user and returns whether or not it's active. So array filter basically, if you're not familiar with that function, if you return a true statement, it'll add it to the thing you passed in, it'll get added to a list, and then you can deal with it. So it's a way to filter things out of a list. So here, if it's active, we're going to add that to our list we're going to pass on. So once we filtered out all of the inactive users, we're going to pass that into another callback. That's going to go through and check all the users for a balance greater than 0. That's going to subset us even further. And then when that's done, that gets passed into another callback for checking the country. So you can see that this is super ugly to read, but also it's really hard to actually follow what is doing what work. We have 3 array filters that are each getting some set of users, and then they all have to do work to filter those things out. It's a really, really ugly way to write this code. So what promises do is help clean up and put a consistent interface to writing a lot of this stuff. So the promise libraries in PHP, they're built off of a spec called Promises A+. Generally, most of them are. But the idea is it actually kind of wraps all of this in an object model to make it easier to structure your code, share your code, and actually pass around these things. One thing callbacks also don't really do very cleanly is handle errors. So like in this case, we're basically resigned to wrapping all this in one giant try-catch block, which if, active account and get balance and get country all kind of throw concrete exceptions, it's not too bad to handle, but now we have one try-catch with probably at least 4 different catches for the 3 discrete exceptions and then 1 general exception. So all of that error logic is kind of stored in your business logic as opposed to letting these things handle it. Promises allow you to actually describe what happens each step for error handling. So if we take kind of a basic look at promises, this is using the Guzzle promise library. Guzzle promises don't have to be used with Guzzle, which is really, really nice. It's just a generic implementation of the A+ model. So you should be able to use Guzzle promises just about anywhere that takes promises. But the idea is we have a fulfilled function that's going to take whatever value the previous step created. Then promises also generally have a rejected function. This is going to be your error handling function. So when we create a new promise, we're going to give it both a fulfilled and a rejected. For the Guzzle library, you can get to the rejected function by throwing an exception. That exception's then passed it into the rejected function. And then you just do what's called resolving. So you get a promise with its 2 functions and you resolve it. Now fulfilled could actually be another promise. It could be a series of callbacks, whatever. But basically, we're going to go through and try to resolve this promise to the best of our ability. So like I said, we create our fulfilled function, we create our rejected one, we throw all that into a promise, wrap it, and run it. If we want to throw in a new promise, then we just do another then. So we do the first promise, then we do the second promise. So this is where the object-oriented structure comes into play. We can chain promises together as much as we want. So if everything works, the output of fulfilled will be passed to fulfilled 2. If fulfilled explodes for whatever reason, rejected gets called, and then we just stop. It doesn't continue on down the chain. If fulfilled 2 has a problem, it will call rejected 2, not the other previous rejected function. So you can go through and add these promises up until you get whatever full amount of work you have. So if we go back to the code we had, and we turn this into promises, we're going to create a new promise. Then we're going to have a function that deals with this. Now I've cut out the error handling just to cut down on the amount of code we have on a slide. But we're going to take that original function and say, given a list of users, just do one simple array filter. So this is much cleaner to read. Then once that's done, we're going to do promise then again. That's going to do the second layer. So this time we're going to get the balance. Then we're going to go through and we're going to get the country list. So this is much easier to read. It is a lot more code, but I think the maintainability of this is much more, has a lot more longevity to it. You can read this and understand what's going on with it much better. So then to actually resolve this, we're going to take the original promise object we made. We're going to say resolve, and we're going to pass it a list of users. And then unless we're doing something that actually kicks it off, we can manually kick it off with promise wait. What that will then do then is go through each of these promises. It's going to call the first promise, pass the output of that to the second promise, and then pass the output of that to the third promise. So it's much easier to follow. And if we need to make changes to this, we don't have to try to figure out which step of the callback structure it's in. We can go through and just very quickly figure out what this is. I've done this with anonymous functions. In real production code, you're probably going to go through and have callables through here, which then makes this even more easy to read because you can pass in invocable objects. You can pass in named functions you've created elsewhere. So you can actually make this even more clean by wrapping this in like a proper service layer, things like that. So a couple things to think about with asynchronous programming. One is workers and queues. If you are thinking about turning a workload into asynchronous programming without having to jump to something like React or things like that, think about a worker and a queue setup. This will get you the power of parallel programming, so you can do things in parallel. And something like Beanstalk is very simple to set up and structure. And then you can start throwing things into queues and then having a number of workers work on them. I've actually solved a lot of problems by doing this, and it handles workloads very, very well, even at very large scales. Beanstalk works up until about 150 workers or so. That's usually about the point where just like networking problems come into play. The Linux networking stack kind of falls apart once you have that many concurrent worker queue connections going on. But you can scale horizontally by just adding workers up and down. So if you want to play with the idea of like splitting your workloads up, look at a worker queue setup before immediately jumping to async. If it works really well with workers and queues, that might be a good candidate for actually doing some async work, as long as you're not having to deal with things that like might take 15, 20 minutes at a time. It's really hard to break things up that take 15, 20 minutes at a time into async stuff, just because, like I said, async by itself isn't going to magically start working, making things quicker. One thing I kind of did sidestep a little bit with this is the idea of generators and coroutines. This is an alternative to an event loop. Basically, the idea with this is generators were added in 5.3, I think it was. The idea behind a generator is it's a function that you can pause and return data back early, and then you can return control to that function whenever you're ready. It also has this idea of a coroutine where when you go back to that function, you can pass data back in and then continue the work. Some event loop systems will actually use this. It works really, really well as long as all of your code understands that it needs to be a generator. A lot of code to work with generators would have to actually be rewritten. So unless you're starting a greenfield project, it's kind of hard to refactor into a coroutine setup. If you're using a language like Golang, those are designed from the ground up to work with coroutines. So the things it does in its design structure work very, very well with coroutines. You don't really have to think about it. With PHP, you have to do a little bit of work to actually kind of restructure your code. But generators and coroutines are really nice ways of getting an asynchronous-like setup. So if we think back to the Twitter example way back when, you can yield at each tweet that comes back and do a little bit of work, pass back to the tweet getting function, and kind of go back and forth through there. So I would recommend looking at generators and coroutines, see if that takes care of some things for you. They're really, really powerful, and if you can rewrite your code that way, that does make it much more succinct and I think usable using a lot of the async ideas. Probably the closest we have to actual real life asynchronous programming is Swoole. So this is I don't want to say an alternative runtime, but it's an extension to PHP that will invoke the PHP engine in a different way. So it's kind of like FPM, but it has a coroutine setup inside of it. So there's a bunch of extra code that you can do to build what I would say are more proper coroutines than what we get in the base language. But it also will run multi-threaded. So you actually get the benefits not only of doing a more traditional async programming like what Node and some other languages do, but you also get the power of parallel programming where you actually will get different threads running and being able to pass data back and forth much more easily than what PHP itself does. So I would heavily recommend looking at Swoole if you want to do a lot of async programming. If you want to take existing programming and just kind of play around with it, ReactPHP is probably the better option because it runs completely in the PHP user land. There's no extra extensions you have to get it to work. There are a couple other event loop and coroutine libraries, but Swoole is probably the best one that is out there, and that's the one that I would probably heavily recommend. So I know async generally tends to have quite a few questions, so if anybody does have any questions, I can go ahead and field those now. Otherwise, like I said, thank you for having me. If you've got any questions after this, after you sat and thought about it, you can reach out to me as Dragonman Tank, generally just about everywhere, especially on Twitter, or feel free to email me, chris@Tankersley.com. If you are interested in working with some of the things we have at Nexmo and Vonage, feel free to DM me. I've got some coupon codes to give you some credit. But otherwise, I think I will open it back up to the floor for any questions. But again, thank you very much.
Cool, thanks, Chris. Let's see. I can't see any questions in the Zoom chat. Can't see any questions in the Meetup chat, in the Slack chat. Does anybody want to just, if you've got questions, just want to unmute yourself and throw any questions out to Chris?
Looks like actually Jamie's asking, what books would you recommend to learn about event loops? I'm going to be honest, I don't know. Most of what I've had to deal with are coming from the JavaScript side of things. I'm not a super great JavaScript developer by any means, but learning how that worked and then kind of digging into the internals of like React and stuff like that gave me a better understanding. So unfortunately, I don't know of any good books that I would recommend.
Okay, I can see Mark, I can see Paul on the screen. Do you guys have questions or?
If I may.
Yeah.
Yeah, go for it.
I've used a lot of asynchronous stuff in queues using like SQS with consumers before.
Yep.
I guess what I'm having slight trouble understanding is if it's running in the same thread in.
Did I die or was that just Mark?
Mark,
Okay.
PHP.
Hey,
Sorry,
Mark,
you
you cut out just as you were asking you were beginning to ask your question. You cut out.
Oh right, sorry.
That's okay.
Weird internet issues, I guess. I was saying, in the context of ReactPHP, if you're using the same thread in PHP itself, how does it speed up the operations exactly?
It technically doesn't, because if you're doing the exact same workload, that workload is going to take the same amount of time as it does with anything else. React only basically allows you to kind of think about cutting the workloads up into smaller chunks just for like order of operations kind of things and deciding like, oh, this doesn't have to happen immediately after this other process. But if something ultimately takes 30 minutes, it's it's going to take 30 minutes in React just because it takes that long to process. That's one of those reasons I said like async doesn't actually magically speed things up. So if you have very long running processes, queues are actually probably your better option than async, because then you can offload that through actual real parallel programming of multiple threads.
So far, I've just used some processes, like in Symfony, for example. You can use the new process to create a background process and process multiple like database imports, for example. And I've used queues for a similar sort of thing, but I've never played with ReactPHP before because I've, to be honest, a little bit struggled to get the concept of why it's making things better.
Yeah, it's like I said, it's not necessarily going to make things better. If you have very heavy workloads, I haven't looked at the Symfony process stuff, but I'm going to guess it probably needs PCNTL under the hood to spawn those out. And raw PCNTL is a horrible thing to deal with, all that work. So if Symfony can make it better, by all means use that. But that's probably spreading it out through multiple threads as opposed to the way React would do it. I think React does have it can use, and I can't think of what extension it is. I think there is an extension it can use to do multi-threading under the hood, but you still have to write your code the same way. So
it's called libuv.
Okay, libuv. Yep.
I saw a talk from the Swoole guy. I can't remember his name. That looks really promising. So
yeah, Swoole. If you really wanted to get a heavy lifting for asynchronous programming, Swoole is probably the best bet when it comes to heavier workloads. The coroutine setup and the multi-threading in that is really, really nice.
Thanks for the talk.
Thank you.
Okay, any more questions from anybody?
Oh, it looks like there's one. Why there have been not so talking about is overkill since web server does most of the work. Okay. I think it has to do mostly with the way PHP apps are developed. Generally, we're not building a lot of things that need to do background processing. And if we are, we probably already have queues set up because it's taken us so long to get to asynchronous programming. A lot of languages had them much earlier than we did. And like I said, we kind of sidestep a lot of that by letting the web server handle it. So a lot of the web stuff, there's probably very little need for asynchronous programming. A lot of the async programming comes up in data processing and more server level tasks, I think, necessarily than I need to serve a web page. So I think that's the reason it doesn't come up a whole lot in PHP.
What types of projects would you, if people are trying to build projects of various different types, what are the key identifiers when building a project to say, that would be a good type of project for asynchronous programming, and that would not be a good type of project? So there's really just the key signifiers for people to digest so that they could, when going forward, they could be like, I remember this point, and this may be an opportunity for async.
Yeah, so the big differentiator for me is whether or not I care what order something is done in. So like processing a web page is really very linear. You have a definitive, I get a request, I have to do some work, I have to respond to that, I need to do that as quickly as possible. So I have to do step 1, step 2, step 3. I can't jump ahead, and I don't want to sit and wait for something else to get done. Most of the time I use it, it's with data processing. So a lot of data filtering stuff comes in that way. So kind of like I showed that active users. If I'm doing a lot of reports, what I may do is start with a list of users and then subset those down and then pass those off to different callbacks or different other sets of promises and let those kind of chunk in the background. Generally, like I said, it's really not going to be the website. It's going to be a lot of background processing. So I tend to do it a lot more with heavy data processing things. Once I get past the 5-10 minute mark or something that like the overall operation is going to take more than 15-20 minutes, then I start looking at like workers and queues. But if it's something that like I can do small chunks of people's work at multiple times, that's when I think about it. So like doing an end of day report and doing small pieces of that, that's where I kind of look at those if I can get those done fairly quickly. like I said, my personal cutoff is probably about 15, 20 minutes. Then I move that to a queue and I actually look at parallel processing.